So what I want to do, what I've been trying to do is come up with a bunch of examples where you deal with the rational numbers in the exponent, basically radicals, basically dealing with radicals, crunching radicals. So I've been trying to come up with a whole bunch of different examples of dealing with radicals and crunching them. And they've been really disjointed. I've looked at the videos and stuff. So I figured the best way to take care of this is probably just do one gigantic problem. And when you do one large problem, it takes care of a whole bunch of little problems in the process. You know, it's just basically like real life. If you take care of one huge problem, you know, a lot of little things get taken care of in that process. So what we're going to do is create a really large problem and then crunch that large problem to an answer. Now I have to come up with that problem, right? So what we're going to do is we're going to start off with the answer, fairly simple answer, and then we're going to expand it. So we're going to basically reverse engineer a large problem. If you remember, if you're a kid, if you're doing mazes, whenever you're doing mazes, you know, you're sitting here, start here, end here. You sit there, you go through your thing. If you ever get stuck, if you don't know how to do a maze, I remember when I was a kid, it's a lot easier starting from the end and going to the front, right? So that's what we're going to end up doing now. So we're going to start off at the end where, you know, the solution is for a really large problem, and then reverse engineer it and create a really large problem. Now, what kind of problem? I just basically want our answer to be, you know, two terms. So let's say our answer is going to be 2 square root of 5 minus 3a squared cube root of a squared. Now I'm making that one a little bit harder because you know, you're going to get hard problems, and that one's going to be fairly straightforward. Now, one thing you got to keep in mind is this answer can appear in a whole bunch of different ways, right? There's just like if you have the number 4, for example, let's use green. If you have the number, let's try this, smaller chunk. So if you have the number 4, is that coming out? Green comes out. So if you have the number 4, you can write the number 4 any which way you want. 4 could be, you know, 8 divided by 2, right? 4 can also be 5 minus 1, right? So all of these numbers up top, the final answer can appear in a lot of different forms. So if for example, if you're getting a multiple choice, if you go into an exam, write a multiple choice exam, you know, there'll be 4 or 5 answers, you know, A, B, C, or D. When you solve a problem, you're not necessarily going to get specifically exactly the way the solutions are laid out. Sometimes you have to crunch the numbers and realize that, you know, number 4 is also 8 over 2. Now you never write number 4 as 8 over 2 because you always want to reduce to the lowest possible form. But when you're dealing with the radicals, I've said before, radicals are really exponents. So your answers can appear as an exponent if you have a multiple choice exam. Can appear as an exponent, or they can appear as radicals. For example, 2 square root 5. So if you have 2 square root 5, they could write this answer. Remember radicals. When you don't have a number up here, that basically means the square root. So it's a cloning. It's a single clone, right? So when you go this way, it basically means whatever number is up here, it clones itself once or twice. Basically, you get 2 clones out of it. So when you go over here, this square root of 2 square root 5 can be, when 2 goes in here, it goes 2 times 2, which becomes 4. 4 times 5 is 20. So you can have this as the square root of 20. Now the final answer, they might write it down as the square root of 20, but they might also write it down as 20 to the power of 1 over 2. Okay? So keep this in mind where this number here can appear in multiple forms. Another way, for example, let's take this one. This is a cube root, right? So if you take these numbers inside the root symbol, it means everything that's going inside is going to clone itself 3 times, and they're going to multiply each other, right? So when the 3 goes in, 3 times 3 times 3 is 27. When the a squared goes in, you got 3 a squareds multiplying each other. And the rule for when you're multiplying, so right now, let's take all this stuff in, right? You got the cube root. You got the cube root of 3. So it's clone itself 3 times. 3 times 3 times 3 is 27. So you got the cube root of 27. Then you have a squared multiplying itself 3 times. So you're going to have a squared times a squared times a squared. And you already have an a squared inside the radical. So you're going to have an a squared up here, right? A squared times a squared times a squared times a squared. All you do with multiplication, when you got exponents, you just add the exponents, right? So you got 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So the final answer for this is, I'm going with 1, all the way to 1. The final version of this could be cube root of 27, a to the power of 8. Right? So for this side of it, this term, they could write it like that. And again, that's not reduced form. But they can also write it in an exponent form. So let's bring this guy down. Remember, the cube root basically means 1/3 of this whole thing in the exponent, right? So it could be, actually, let's do this now. Let's draw a wall here so we're not getting confused with these guys. So this guy becomes 27 a to the power of 8 cubed. To the power of 1/3. So your final answer might appear as 20 to the power of a half minus 27a to the power of 8 all to the power of 1/3. And again, that could be reduced written in a different way, right? So it really depends what they're testing you on, and it depends how good you are at crunching numbers. The other way, if you're going to write this thing as an exponent, one other way you could write it as, room up here? We've got sort of semi-room here. Another way they could write this as would be 2 times 5 to the power of a half minus 3a squared a to the power of 2 over 3. So when you're, obviously this would be in one line, right? And this is multiplication here. So whenever you're crunching numbers, what you really want to do is reduce it, take it to the lowest form possible, and hopefully whatever exams you're writing, they're going to stick with one convention, basically. If they're going to deal with radicals, they're going to keep the answer in the radicals. But if they want to throw little tricks here and there, what they might do is kick it into the exponents, okay? So for the radicals, what we're going to do is create a super problem. I guess we're going to create a big problem. And this is what we're going to look for the answer. 2 square root of 5 minus 3 a squared cube root of a squared. Okay. Let's go find another wall and see where we can take this and how far we're going to break it down. Okay.